Oh my goodness, another IDP talk. Feels so 2022. Okay, before we get things started, who of you guys here in the audience already has an IDP, Internal Developer Platform, in place, or is in the next years maybe planning to go for platform engineering? I want to see some hands. Okay. So let's get things started. So for everybody here who wants to go for an IDP or platform engineering, that's the right spot to go for today. And my name is André, and I work for Bechtle. Bechtle is the largest IT system house in Germany, and I work there already since 13 years, and I run DevSecOps and platform engineering practices in a competence center in Bonn, and we are around 150 people. And yeah, today I will guide you a little bit through the architecture of our IDP and how we did things. So it's really how we did things. It doesn't mean it must really fit for you. But I think it's a pretty nice approach, and I'm pretty happy that I can today share my experiences. So also a big thanks to Karina and Pete making this possible, and let's get things started. So as I said, we have to solve a lot of problems every day. Yeah? So the competence center where I'm from, we develop microservices since 2014. You can now imagine what kind of Frankensteins and nightmares we ever saw in the past. Yeah? And we deliver this kind of applications to highly regulated customers. Highly regulated customers in Germany are customers that operate critical infrastructure, could be customers in the defense segment or in the federal public sector segment. And the case I show today is really specifically meant for these kind of customers. Yeah? And we have a lot of challenges with these customers. Yeah? We really need to deploy to multiple environments. We need to deploy containerized workloads into multiple environments. Yeah? And definitely in Germany, I can tell you, the skills gap is there. Yeah? I don't know how it is in other countries, but in Germany, especially public sector customers, they have lack of skill, and that's really a big problem. And we need to really deliver also the high security standards to these customers. And with this, I would like to mention also for you guys how we really architected our IDP. Yeah? So the IDP is something we use internally for our developments, but we also deliver the IDP as a product to our customers. It's like eating your own dog food. The concept is really the separation of concerns. Yeah? What I all the time saw in the past is that you don't really want developers to write Terraform stuff or to write Ansible playbooks or to give their Helm charts to the ops. Yeah? So some developers think they can do it. Maybe they are capable of doing it. Yeah? But when we now think of a critical infrastructure, it's not the reality that if you are a customer who really works together with external service providers developing software on top of the platform, that you want these developers to get information about your critical infrastructure. Yeah? So we really try to separate developers from the platform team. One example is also that we really try the observing systems, for instance, only to have read access to the runtime environments, to the productive environment. So I will guide you a little bit through our reference architecture. And for some of you guys who are more into platform engineering, this might look very familiar. Yeah? And we did not reinvent completely the wheel, but experts could maybe see that we changed some stuff. So we sliced the architecture into planes. Yeah? I don't have right now a proper pointer to guide you through my diagram, but I'll try it with my voice. So the idea is to make it really easy and comfortable for developers to develop and deliver their workloads on top of the platform. For that, we, as you can see, use the Red Hat Developer Hub. Yeah? And it's really convenient for developers to start working on the platform there. Yeah? It would be, in our case, also possible to use GitLab templating. That's also what we use. But at the end, the target always is to deliver your containerized workload onto a so-called resource plane. Yeah, that's topic number one I will dive deeper into. Yeah? And as you can maybe also see on the chart, there are 3 resource planes in this case. We have a resource plane that's hosted on Azure. In this case, it's AKS, maybe a very bad word here on the comments, yeah, but it could also be OpenShift on Azure, yeah. But for you guys, it's a public cloud, and then there we have also 2 data centers where we have a classical on-premises infrastructure, and the red line also shows that this data center is air-gapped, and this is a special challenge I will really jump into. Yeah? Being air-gapped for us could also be named as the dark side, yeah? But at the end it's you don't have internet. And you have to be very creative to deliver containerized workloads into this environment. But speaking of creativity, we have really the chance to also, hopefully you can see my slides changing. Okay, now. So as you can see here, part number 2, I will dive with you guys into how we define workloads that need to be delivered onto the resource plane. Yeah, that's part number 2. And then we will also dive very deep into how our platform orchestrator from Humanitech is utilized in this case. Yeah? And I think it's really fun, and I will have a detailed process for you later on. Speaking about the resource plane, I really wanted to thank IBM making this possible. Yeah? So we as Bechtle operate IBM Fusion HCI systems over multiple data centers. Yeah? So they deliver proper storage, yeah, backup, S3 we do at scale with Fusion, and also, what's really convenient for us, and I know that Daniel Danner is now watching this. Daniel was the guy helping us out to deliver this Fusion system into our data centers, and he planned to do it in 5 days. And it's true, he did it in 3. Yeah? So you get a complete HCI stack with bare metal OpenShift on top, and Daniel with the team delivered it in 3 days. And for us at Bechtle, that was really amazing. Yeah? We were so amazed that we made a video about it. So everybody wants to watch the video, can take a picture of the QR code. Yeah? And definitely you will get some more information around that, and also how we integrate the Fusion into our CI/CD pipelines. Yeah? There are some amazing things like backup and so on. Just check it out. So I will directly jump into the right topics here, into the definition of workloads. So we define our workloads, or we specify our workloads with the open source project SCORE. And at the end, you can just say SCORE enables the developer just to say what does his app need, and he doesn't need to define specific infrastructure, resources, and so on. Yeah? He just says, my application needs a Postgres database, and we need some DNS and so on, and things will run like a charm. And I will guide you a little bit through how this is happening. For us, really, the key points are that if we work with the workload specification SCORE, we can really do the configuration one time, and it's possible for us to deliver onto multiple platforms. Yeah? So we can easily deliver it, of course, to our on-premises OpenShift environment. We could also deliver this workload into a public cloud. Yeah? That's really, for us, very convenient. And I always say, that's a real multi-cloud scenario. Yeah? It's not like you buy a hyperscaler number 1 and 2, and you say you're multi-cloud enabled. Yeah? So this is really ready for proper multi-cloud scenarios. And this is an open source project, and as you can also see later, it's sandboxed by CNCF, yeah, and this was this lately happened. Yeah, so to summarize that, SCORE is really developer-centric, and it's declarative. It's very easy to learn. I this morning talked with a friend of mine, and he said, "Yeah, but we have Helm." Yeah, of course you have Helm. We all have Helm, but if you just check out the YAML definition, you can see that there are maybe some things in which you cannot do actually with Helm, and you will also later on see why. Yeah, the developer here really defines his workload. saying like, I want to have a Postgres database in this case, and my connection string to the database looks like that. Yeah? And we really try to put an abstraction layer, yeah, over the platform engineering team to the developers. Yeah? And we don't want developers to throw things over the fence that mess things up. Yeah? That's really what we don't want. And yeah, we had this multiple times in classical DevOps approaches, which were not really DevOps, yeah? And we really, at the moment, love this approach. Less things break, believe me. Good. As I said, it's a CNCF project, yeah, and in 2024, it was sandboxed, so check it out. Maybe you can contribute, and really fantastic team around SCORE. So let's dive a little bit deeper how this works. Yeah? So at the end, we specify the SCORE file, and then we have a so-called SCORE implementation. And yeah, surprise, what happens if you take a closer look at the right side? All the artifacts are produced by SCORE that really define how your app should work. Yeah? And the developer at the end doesn't have much effort with it. I will also show you later on how the work is split up over the teams. Yeah? Now, something has to really understand what this SCORE file does. And for that, we decided to use the Humanitech platform orchestrator. Yeah? You should check the guys out. Yeah? It's really a cool piece of software. Yeah? It's really amazing. Yeah? And this thing really also helps us to get the load from the DevOps engineers. Yeah? You will also see later how this works. Yeah? Really a recommendation from my side to take a closer look on that. But actually, I promised you to show also how we deliver into air-gapped environments. That's what we jump into now. Yeah? So how is actually the process? Yeah? So we read the SCORE file, and we then match a proper template for the resources that are needed by the application. Then we create everything, yeah, that's really necessary to do your deployment. And I had to explain this to a little older colleague of mine, and I told him, you know something, it's like the old MSI packages, you know, from the past. Everything is in, and you can just deliver it somewhere, set up XA, and then things will go. It's at the end simplified a little bit like the story. Yeah, and then when you have all the things together, you go for the deployment, and to really look closer into the process, how is everything now stitched together? You can see on the left side that the developer, like I said, defines his workload. Yeah, he would just say, I need Postgres, I need some DNS, and so on, and I maybe need a sizing for my application, t-shirt sized, SL, whatever. Yes, you're very free how to define that. Yeah? In parallel, the platform engineer will then really define how, of course, these workloads should be observed, how these workloads should be provisioned, and he will create a kind of rule set out of that. And the developer only checks in a SCORE YAML file into his repo. Yeah? And then the normal CI/CD magic will happen. But the Humanitech operator will take all the artifacts, yeah, and again will then decide, is it a staging environment we want to provision, or is it maybe just a dev environment? Yeah? And with this kind of tagging strategy for the environments, we have also a very high flexibility to deliver the workloads to the right place. Yeah? So up here, it's quite simple. Yeah? Everything is right now in Git, but how do we now bring everything to this air-gapped environment? Yeah? So at the end, we could also just take a removable media and carry all the data into a bunker or onto a boat. Yeah? It's totally up to you. We can make a push to remote, we can create a patch file, whatever, but everything is then back in Git. Of course, you have to take care to have your latest container images in the registry available. And then we do a very standardized GitOps process. Argo will just pull all the information. Most of the time, these kind of customers, they have autosync turned off. And I always say, if autosync is turned off, it's not really GitOps. Yeah? but the functionality here really works totally fine. As soon as all the information got really through Argo, the normal way of deployment will start, but Humanitech offers an operator, and you can put this operator, of course, in OpenShift, and in our case, the operator resists in our bare metal OpenShift environment and runs there. And the operator then takes care that everything will be delivered. It will also take care to create the necessary resources. And you can see at the bottom that we have some drivers. In this case, you see that we internally use Terraform drivers. That makes it also very easy for us to define the resources over Terraform, because everybody who knows how Terraform works can use that. But you're, with this concept, also free to just build your own drivers. You're very open in the system to build your drivers. What is a driver in this case doing? The driver really takes care that, in our case, also a virtual cluster is provisioned on top of the bare metal OpenShift. We want to, in some cases, for dev environments, want to work with virtual clusters. And also, we all the time create complete new clusters in this case. But the drivers could also now take care to provision your Postgres database. That's also not a problem. So the driver can do really both. And the cool thing about that is that all the resources that are provisioned, I can later on check back in the portal where the resources are provisioned and which microservice or which application uses which resource. It makes it very transparent for us also really to get this assets managed from our side. We have very deep integrations also into our incident response management, that we create also automatically business services out of this information Humanitech in this case is delivering us. And with this, I think customers who are highly regulated can really work well. Sometimes I don't know why highly regulated customers want to deploy microservices into air-gapped scenarios where the processes are more legacy. I always say you could also normally take a monolith. When you do 2 releases per year, I don't really see directly the advantage for microservices, but we have customers doing that, and we also do it because our customers want it. And from my perspective, this is really a very nice solution. And this solution was built with Red Hat, with IBM, with Bechtle and Humanitech. And I will just leave you now with the benefits that we see with this solution. And I think delivering that always needs a good team. And I really wanted to thank the guys in Bonn supporting all of that. I wanted to really say thank you to you guys. And I also wanted to thank the audience taking your time. And if we would have some seconds, I'm open for questions. Thank you. So it's pretty hard to see anybody because of the light. Don't be afraid to lift your hand if you have a question. Okay, hopefully, oh, no, there I see someone.
Hi.
Hi.
Ram from Red Hat. So actually, in the air-gapped environment, you have a big cluster of OpenShift. So I was just wondering, is it so deployed on top of your bare metal instances, so inside a VM on top of OpenShift, so OpenShift virtualization using OpenShift in order to create your environment, your big cluster?
Yeah, your assumption is totally right. And,
okay.
The good thing is that IBM Fusion supports this with the latest release, and we just switched it a couple of weeks ago. And the scenario, how you see it there, is supported by IBM in the Fusion, and you can automatically configure it. You can automatically configure the box like that.
Okay, thanks.
Yeah, you're welcome. Don't be afraid. Okay, so if there are no questions anymore, I wish you all a nice Kubecon, enjoy, and yeah, have a great day. Bye-bye.